everyone. Continuing on our trig graphs unit, today we are going to be looking at the frequency and the period. Now, for this lesson, I'm trying a new way on how to write while I'm talking on this little pen pad thing. So if I mess up a lot, I'm still getting used to it, so just bear with me. So, the do now says, what is always true about y equals 0.5 raised to the x power? So, notice it says things like it is always increasing, it is decreasing. So let's figure out what this graph even looks like. So go to the calculator, y equals, and we type it in, 0.5 raised to the x. Let's look at the graph. Now, I'm going to see if I can drag this onto the screen. If we look at this graph, okay, we always read graphs from left to right. If you're reading it from left to right, the graph is decreasing. So that means we can eliminate answer choice A. Now, it's between B and C. B says there is an asymptote. Now, an asymptote, in case you forgot, is a line that the graph never crosses. Okay, so it gets really, really close, but it never crosses it. Now, it is at x equals 0. X equals 0 is a vertical line. It is this line right here. Now, the graph very clearly crosses this line, so that means x equals 0 is not an asymptote. Now, the big misconception here is that x equals 0 is this line here. Now, this line here is actually y equals 0. So there is an asymptote, but it's not at x equals 0. It is at y equals 0. So that tells us that our answer here is B. I know that it looks like it's leveling off, but the graph is just getting really, really close to the x-axis, but it never actually touches it. Okay, a little vocabulary review. Amplitude is the vertical distance between the midline and one of the extremum points. So extremum, again, are your min or max points. Then we have a vertical shift. A vertical shift is the translation of the graph up or down a certain number of units. Period is the horizontal length to complete one cycle. Now you have to know what sine and cosine look like for this. So the sine graph, let's say this is our midline. Sine starts at the midline, then it goes above, then it goes to the midline, goes below, back to the midline. So it makes this kind of an S shape. On the other hand, cosine, let's say that is our midline. Cosine starts above, then it goes to the midline, then below, then midline, then above. So it goes like that. Okay. And lastly, the frequency. The frequency is the number of cycles the graph completes in a given interval. Okay, today we're going to be looking at period and frequency. It's the final sinusoidal, however you pronounce that, transformation. So usually our period is 2 pi, but today that is going to be changing. So remember, the period of a sinusoidal graph is usually 2 pi. So that means it takes, the amount of time that it takes to complete one rotation is 2 pi. But the period depends on b in these equations. So if there is a number in front of x, that represents your frequency. Okay, so since b in our sine and cosine functions is the frequency, you can't exactly get the period from that. What you have to do is a little bit more work. You have to use this formula right here. Now, unfortunately, this is something you do have to remember. It is not given to you anywhere. Okay, so we're going to practice finding the period and frequency from a couple different examples. So first, looking at A, we have 3 cosine x. Now, the frequency B, we usually have a function written as so. A sine B x plus C. Now, this could be sine or cosine, but the frequency is right here at B. If we look at this example, there's no number in front of x. That means the imaginary number is 1. So to find the period, you use period equals 2 pi divided by the frequency. So period is equal to 2 pi divided by 1. 2 over 1, that just gives us 2 pi. So our period is 2 pi. Moving on to another example, in the parentheses we now have a 2 attached to the x. That tells us that our frequency is 2. So to find the period, we use 2 pi divided by b. So it is 2 pi divided by the frequency, which is 2. 2 divided by 2, those can cross out. So we get that the period is equal to pi. Okay, now looking at the last example, our frequency is the number in front of x. The number in front of x is 1/2. So we're using the formula 2 pi divided by b. Now, since b is a fraction, I'm going to be writing this a little differently. I'm going to be writing 2 pi and then the division symbol, 1/2. I do this because we need to use keep, change, flip here. So we keep the first, change to multiplication, flip the second. 2 times 2 gives us a 4 pi. So our period is equal to 4 pi. Okay, moving on. It said determine the period of the following and give your answer in exact form. If it says exact form, that just means leave pi in your answer. Okay, so looking at the first one, our frequency is 4, so we have to use p equals 2 pi divided by the frequency. So the period is 2 pi divided by 4. Now we can simplify this. 2 over 4, that simplifies to 1 over 2. Now we technically don't need that 1 in there, so we can just have pi over 2 as our period. Okay, moving on. So in this case, our frequency is pi over 3. So I'm always going to start by just rewriting the formula, as you can see, just so you get used to it. So the period is equal to 2 pi. Since the frequency is a fraction, I'm going to be writing it like this. So we know to use keep, change, flip. So we keep, we change, we flip. Now when we do this, you can write 2 pi over 1. The pi's end up canceling out because 1's on the top and 1's on the bottom. So you just have to do 2 times 3, which is 6. So the period is 6. Now looking at the last one, Our frequency is 2 over 3. So period equals 2 pi divided by b. I'm going to write it with the division symbol so we know to use keep, change, flip. So keep, sorry, that should have been a change. Change, and then flip the last fraction. You could put this over 1. Now notice the 2's are across from each other. So we can actually cross out that 2. So then we're just left with 3 pi is equal to the period. Okay, now a lot of the times questions are going to ask you to graph exactly one cycle. So if you're asked to do that, you need to find the period. You need to know how long it takes for one cycle to be completed. Then you're going to make the period the last point on the graph. So the fourth box on the x-axis, and then you graph as normal, how we've been graphing. So let's look at this first example here. Now, notice that there is a frequency here. If there is a frequency, you have to find the period. So the period is 2 pi divided by the frequency, which is 2 pi divided by 4. We can simplify 2 over 4 a little bit more to pi over 2, or 1 pi over 2. Now, we're going to go 4 boxes from the origin. So 1, 2, 3, 4. This fourth point here, we are going to label it pi over 2. So that is where our graph should end. And now we can graph it as normal. So we need the amplitude and we need the midline. So our midline is usually where C is, but we don't have a C here, right? We're not adding anything. So our midline is just at y equals 0. Now our amplitude is this number here. So our amplitude is 2. Now this is the distance to get from the midline to the max and from the midline to the min. We have a sine graph, so first let's draw our midline at y equals 0. Since it's sine, it starts at the midline, and then we go above. To get to that point, we have to use our amplitude, so we go up 1, 2, back to the midline, go down 1, 2, back to the midline. Notice we stopped at our period, so now we connect. Oops. Messed up that a little bit. Connect with one smooth line, and now we just graphed one full cycle. So the only difference when you're given a frequency is you will have to write what that last point is. Let's try another one. So it says graph exactly one cycle of this. Now it gives us a frequency, so we need to find the period. So the period is 2 pi over the frequency, so 2 pi over b, which is 3. So our fourth point, 1, 2, 3, 4, this is going to be 2 pi over 3. Let's get what our information is. So our midline and our amplitude. Now, our midline is over here. It's at positive 1, so it's at y equals 1. Now, our amplitude is found in front of cosine, but it says negative 1/2. Our amplitude is only a positive 1/2. That negative gives us another piece of information. So the negative tells us to flip the graph. okay? So we start it the same. So we start by graphing our midline. Our midline is at y equals 1, which is right over here. And now we use the midline to graph the rest of our graph. Now, since we have to flip it over flip the graph over, what I'm gonna do first is kind of plot the points of normal cosine without the negative, and then I'm gonna flip those points over. So cosine starts above the midline. We should go 1/2 space above. So it should be about there. Then we go to the midline, then we would go 1/2 below, then we would go to the midline and go 1/2 above. Now, since we have to flip the graph, our minimums and maximums are going to switch. So this was a max, it becomes a min. This was a minimum, becomes a maximum. This was a maximum, it becomes a minimum. So then I'll just go back and kind of get rid of those 3 points. And now we have a graph that's flipped over. And that is one cycle of our cosine. Okay, so if the period of a sinusoidal function is 18, which gives us the frequency, we only have one formula to help us with that. P equals 2 pi over b. Now, they give us p. So they give us that the period is 18. So we have 18 equals 2 pi over b. And then we have to solve this. To solve this, what you can do is you could put 18 over 1 and cross multiply. So we have 18 times b, which is 18b. And then we have 2 pi times 1, which is just 2 pi. Now, to solve for b, we have to divide both sides by 18. The 18 will cross out and we get b is equal to 2 over 18 simplifies to 1 pi over 9. But again, we don't really need that 1 there. So it just simplifies to pi over 9, which is answer choice 1. Okay, so to get credit for this class, you have to complete this check for understanding problem on a separate piece of paper and then upload a picture onto Google Classroom. Okay, have a great day, everybody.